Assalamualaikum warahmatullahi wabarakatuh. Today, I will present to you about my general presentation. My title is about nanocoatings. First of all, my name is Muhammad Ibuddin bin Muhammad Rozai and my matric number is A17MJ3009. Okay, first let me explain to you about the super hydrophobic. Due to the possible application in impermeable textile, self-cleaning coatings, laboratory-on-a-chip system, microfluidic device, and others, the principle of super hydrophobicity has been widely exploited over the past decade. A surface is defined as super hydrophobic when its contact angle is more than 150 degrees and the sliding angle is less than 10 degrees. This phenomenon is naturally observed in numerous biological processes such as the lotus leaf, the desert beetle, and the water strider. For the experimental methods and materials, first, we can move to the preparation of silica based on nanocoatings. By mixing 250 gram silicon sealant and 40 gram organically modified silica aerogel with 2 diameter cubic of turpentine, the super hydrophobic coating solution was prepared. The mixture was stirred at 500 rpm for 1 hour and then put in ultrasonic bath for 10 minutes. The silica coating viscosity was optimized at the value of 1.2 pascal second. Deep coating and spray coating methods were used to apply the nano coating to the natural rubber glove surface. The second one, the preparation of compatibilizer solution. Using an acceptable binder, the nano coating and the rubber surface were compatible. Combining the polychlorophene binder, that is 500 gram with ethyl acetate, binder solution was prepared at a 1:1 ratio, as a mixing ratio. The starting mixture was stirred at a room temperature at 500 rpm for 1 hour, followed by ultrasound sonication in an ultrasonic bath for 10 minutes. The viscosity of the binder after several trials at a value of 1.4 pascal second, the solution was optimized. Next, the application of silica nanocoating on supernatural rubber gloves, deep coating method. The vulcanized natural rubber gloves were placed on a ceramic former and dipped for 10 seconds in the binder solution, after which the former was removed. Then, the former was rotated for around 40 seconds in all 3 directions. Then, the glove coated with the binder solution was immersed in the silica solution for 10 seconds at a 30 cm deep length. After that, the glove was slowly separated from the silica dissolution. After 15 second withdrawal time to a 30 cm length to acquire 2 coatings, the process was repeated. The glove was cured at 50% in an oven with 50 degrees Celsius for 24 hours. To coat a rubber film where the nano coating did not contain silica aerogel, the same process was repeated. As you can see, figure 2 shows the appearance of a water drop upon contact with the coated and uncoated films. As you can see in the figure A, uncoated rubber surface of the water droplet, and B is silica nanocoated rubber surface of the water droplet. Next, the characterization. The first one is the water angle contact and a sliding angle measurement. To calculate the water, a goniometer was used to the touch angle of rubber films that are coated and uncoated. To capture the image that was set on the goniometer unit, a high resolution digital camera such as Canon macro mode was used. The size of the water droplet used to calculate the contact angle was about 5 microliter, and the diameter of the droplet when it settled on the rubber surface was about 1 mm. To measure the average contact angle value for each sample, 5 replicates were used. With a sliding angle measurement device where the water droplet volume used for the measurement was microliter, the sliding angle was measured. Water droplets were kept on the system flat surface. At the sliding angle, where the critical angle where the inclined plate starts sliding down a water droplet with a certain weight, it is measured. To measure the average sliding angle for each sample, 10 replicates were used. Next, we move to the results and discussion. As a mechanical properties, to compare with the uncoated glove, tensile and tear properties of the super hydrophobic gloves prepared by the spray and the deep coating methods were compared with those of in the table 1. The properties of spray-coated gloves were identical to the uncoated gloves, while the dipping technique found a substantial degradation in mechanical properties when the gloves were coated. In comparison to the spray coating process, the rubber material is exposed to organic solvents for extended time periods during the deep coating, contributing to the natural rubber material swelling. As we can see in the table 1, these are the mechanical properties of the coated natural surface. Here are 6 properties. As we can see, there is cure time, the cure temperature, the tensile strength, the mode of 100% megapascal, the mode of 100% megapascal, and the zero strength. Okay, thank you. That's all from me.